Hello, in this video, let's talk about the definite integral. We have discussed the indefinite integral, which is the integral without the numbers. And when you don't have the numbers, we add plus c to the answer because there are multiple solutions. When we have the numbers, on the integral, this is called definite integral. And what it does is it finds us the area underneath this curve from the bottom number to the top number. So visually, if we were to picture, what does it look like? What does the function y equals 2x looks like? Well, y equals 2x is a straight line. It crosses the axis at the origin, and then it has a slope of 2 over 1, so 2 up, 1 over. So it's a line that goes like this. And we are asked to find the area under this curve from 0 to 4. So if we look on the graph from 0 until 4, here's 4, what is the area underneath this curve? Well, that happens to be the area of a triangle. What is the area of a triangle which has the base of 4 units and the height being twice as much is 8? Well, that would be 1/2 of the base times height, which is 1/2 of the base, which is 4, times the height, which is 8. Half of 4 is 2, and 2 times 8 is 16. So geometrically, we already know the answer. The integral is going to be 16 because that's the area underneath our curve. Now let's use the formula to get the same answer. So when we're integrating, 2x, we use the power rule. So the power rule says that when we have the integral of x to the n dx, that equals to x to the 1 power more than what you had divided by that power. So we had 2x to the 1, we're adding 1 to it, it becomes x to the 2 divided by the power. We already had a 2 in the front, so now we have x squared. Now these numbers are the boundaries of our integration. So the bottom number tells us where to start, where the integral or the area begins, and the top number tells us where the area ends. So the beginning, the end. So we're looking for the space between these 2 points. Excuse me. Now, the way we evaluate it is we have this line. It's supposed to be more vertical, and we have 0 and 4. So the way to evaluate is we substitute the top boundary first. So we have x squared, but instead of x, we put the value. So we have 4 to the 2 minus, then we plug in the bottom number to the 2. And 4 to the 2 is 16, minus 0 is 16, which is the same answer as what we had with the graphical approach. So to find the area under the curve, all we do is we apply the rules for the integral, and then we take the top number minus the bottom number. Why does that work? Well, when we have the top number, it tells us what is the area from 4 all the way to the left, to forever. But we don't need all the way to forever. From 0, the integral of 0 tells us what's the area from 0 to the left, forever. And if we take 4 from 4 to the left minus from 0 to the left, we will cut off all the stuff that we don't need, and we will only be looking for the area between 0 and 4, and that's exactly what we're looking for. So that's what the formula is for the definite integral. We apply the rules for the integration, then we take the top number minus the bottom number, because that's the right side minus the left side, the right side minus the left side is the area in between. Now let's use the same technique on 2 more examples. So here is the area of 5x. Now what does it mean? Oh, sorry, of 5 dx. That means there is no x, so x is to the power 0. If we add 1 to it, we get 5x from 1 to 5. So substituting the 5, we get 5 times 5 minus, substituting the 1, we get 5 times 1. Well, that makes 25 minus 5, which is 20. So the answer is 20. Now let's see if it makes sense geometrically. What is y equals 5? Well, y equals 5 is a horizontal line that goes through 5. 1, 2, 3, 4, 5. So it's a line that runs like this. Now we're asked to find the area from 1 to 5. So when x is 1 until x is 5. So here's 5. So from this cutoff point to this cutoff point, what is the area? Well, that's a box. It's a box that has the base is 4 and the height is 5, and the area is length times width, which is 4 times 5, which of course is 20, and that's exactly what we have found. So that's a geometric interpretation of what we're actually doing. Now, one more example. Here we have x cubed. The x cubed looks something like this. It's symmetrical, and it's the same on the left side as it is on the right side, and we are asked to find the area between -1 and +1. So let's say this is -1, and let's say this is +1. Now the area is, let's do this formula. So using the power rule, we add 1 to the exponent, that makes x to the 4th divided by 4. Now we plug in -1 and 1. So parentheses minus parentheses. Each one is over 4 to the power 4 to the power 4. First time x is 1, and second time x is -1. Well, 1 to the 4th is 1, and -1 to the 4th is also 1. Remember, we're doing following the PEMDAS, the order of operations, and parentheses and exponents are before the subtraction. So first we're doing the exponents. -1 to the 4th, is +1, and 1/4 minus itself is 0. So here is the final answer. The answer is 0. Now, it seems odd at first that the area would be 0 because it seems like there is no area. But there is clearly area because I can see it right here. So why is it 0? The reason it's 0 is because when the area is under the x-axis, below, it's a negative area. So this area is negative each time it's below. And this area is the same amount is positive. When the curve is above the x-axis, the area underneath it is positive. When the curve is below, the area underneath it is negative. So when we take the same positive area plus the same negative area, the two cancel off and give us the answer as 0, even though we can clearly see that the area itself is non-zero. It just happens to be that there is exactly the same positive as there is negative. We will see the same situation when we try to integrate the sine or the cosine on one period. So if you take, let's say, sine, and it goes like this, and on the other side it goes like this. So if we take from the negative side to the positive side, this area would be negative equals to this area positive. And if we integrate it from this corner to this corner, the answer once again will come out to be equal to 0, even though the area is non-zero. So that's just something to remember, that the area under the curve below is negative, the area under the curve above the x-axis is positive. And that's how to use the definite integral and how it relates to the integral to the area under the curve. And that's it for this video. If you have any questions on anything, please let me know. Thank you for your time.